Okay, like I said, good morning from Boca Raton, Florida. My name's Dirk Smith. I'm president of Ionics Gas Technologies, and my experience is in the natural gas distribution business. But the purpose of this seminar, and let me just make sure I'm getting everybody in here. Hold on here. And the purpose of this seminar, I'm going to teach this to you from the point of view of somebody in the natural gas distribution business, with the emphasis on what you as a first firefighter responder need to know about natural gas ignitions. And so that's the purpose of this. You're going to find that I'm not going to talk to you about how to set up your equipment and your perimeters and all that. You know that stuff. That's not what I'm here to talk to you about. I'm talking about what I teach when I go to teach in classes to the natural gas distributors, natural gas companies, their people. When I sit there and explain to them how ignitions start, that's the information I'm going to share with you. I teach that class so they don't get injured. And this is the same material edited down from your point of view so that you know how to respond to a natural gas emergency. Okay? Now, you're going to see a video here. This video is about 20 years old. I apologize for the quality. It was recorded on a video cam when it was broadcast over the air television in Oklahoma City. The reason it's important, it's the only instance I know of recorded where you see an actual natural gas ignition happen on camera. And so it's important for you to see what's going on here.
A natural gas explosion rocked an Oklahoma City neighborhood just before noon today. Workers were trying to repair a ruptured line at Northwest 131st and MacArthur when the gas ignited. Newsline 9's Heidi Browning joins us live from that neighborhood. Heidi?
Well, Kelly, there's a bit of a mess out here in the neighborhood. You can see behind me what's left of a fence, charred remnants of the posts, and quite a lot of digging that's been done to make repairs to those lines. But people coming home this evening will find a much calmer scene than what many people saw this morning. It started as a fairly routine repair job. ONG workers were trying to get the gas turned off after a 2-inch medium pressure line was accidentally cut. Suddenly, the gas exploded, sending huge flames into the air. 2 workers received minor burns. ONG officials say there's preliminary speculation that static electricity in the plastic pipe somehow caused the explosion. It took about 30 minutes to control the fire and get the gas turned off.
Now, as a first responder, as a firefighter, this is generally the main cause of natural gas leaks. It's what's called third-party damage, where a contractor cuts into something or some kind of third party has damaged a line and you've got a leak. But the important thing to see in this video is these were professional. This is Oklahoma Natural Gas employees at a leak site in Oklahoma City. And there's not going to be anything that's going to cause an ignition of a leaking gas line. These guys are savvy guys, just like you. They would not have anything present that would cause an ignition of natural gas while they're working on it. So the question then becomes, how did it get started? What caused the ignition on this blowing line when you have people, gas line, when you have people there that know what to do to prevent an ignition? So that's what we're going to talk about. The phenomenon that causes leaking gas lines and propane lines to explode, so you can understand what the mechanism is when you have to respond to a situation like this. Now, this chart I'm showing you right now is from Aegis Insurance Company. Aegis Insurance Company insures the most, like 90-95% of the natural gas distributors in the United States. And this is what they pay out in claim. This pie chart explains what they pay out. I think this is 2023 when it was done. But this is a pie chart showing where this insurance company pays out their claims, what causes their claims loss. And if you look here, you can see that fire and explosion are 81%. They constitute more than all the other loss causes combined. And so even though fire and explosions are rarer events than vehicular accidents or property damage, they're by far the most expensive. They're by far the most expensive. So that's what that tells you. So here's what I want to leave you with when we do this today. This is based on what I teach natural gas company workers. I want you to have an understanding of static electricity as the probable cause for most ignitions when we have polyethylene or plastic gas pipelines that you will encounter. And this has been done, the natural gas distribution industry paid the Gas Research Institute and other places to go investigate this and explain to them what's going on. So I'm going to share that research with you. Now, I'm going to be talking primarily about polypipe because in the natural gas distribution pipe, in the downstream, what we call the downstream or local markets, everybody's moving to plastic pipe. There is metal pipe out there, but that is going away as gas services by law are required to be renewed. They replace them with plastic pipe. And so we'll talk about plastic pipe. So we're going to primarily talk about static electricity and plastic pipe, but it'll also apply to metal pipe. It's important you understand that what we're going to talk about is it applies the same to propane. So you have a lot of people have propane heat out in areas, outside service areas of local gas distributing companies. The principles that we're going to talk about here are the same for propane. I want you to be able to recognize where the ignition risk originates in a gas leak. That's one of the things when you're called to a scene and you go out there, I want you to know where you should be looking for the possibility of a static ignition. I'm going to review static suppression procedures to prevent an ignition. These are the ones that I teach the natural gas companies. I teach, up in the Northeast United States, it's called the Northeast Gas Association. All the major gas companies in the United States, Con Ed, NatGrid, New Jersey Natural, all those guys up there, Eversource, all these guys up there come to this school. It's a 3-4 day school up in Rhode Island, and I teach the class on static electricity. So I'm going to tell you the appropriate procedures to prevent static ignition for what you're going to do. They do a lot of other things in their operations that you do, so I'm not going to bother talking about that. But I'm going to talk to you about how the static suppression procedures relevant to what you would see in a natural gas leak response, what you should do. And finally, I want to give you some guidelines to develop a coordinated gas emergency response with your local gas companies. Down here in South Florida, we have TICO, some of the local guys, local emergency response. I'm drawing a blank now. Palm Beach Gardens Fire Rescue. They have a coordinated plan with the local gas company of what they can and can't do. So I'm going to give you some guidelines on how to develop and approach your local gas company and get a coordinated gas response team. Now, as far as you guys are concerned in firefighters, you're going to go to 3 different locations if you have a gas leak. And I'm going to explain the natural gas transport system very quickly because you could possibly respond in one of these 3 areas. Hold on, I got another person to bring in. Okay. So in gas transport, the first stage is what we call production and gathering. That's where they sink a gas well or an oil well and they take the gas out of the ground and they start to bring it into pipelines. Now, most of you will never, ever see a fire or third-party damage on a gas line in production and gathering because most of these areas are in remote places. But not all of them. For instance, in Dallas, there are gas wells in near residential areas, very close to residential areas. So what will happen is you can possibly have a gas line coming from a gas well in a residential area that you might respond to. And they'll always generally be taking this gas in plastic pipe, not metal pipe. But the thing that's concerning about this is many times this gas will not be odorized. In other words, in all of the local areas, when you have locally delivered gas, it is treated with mercaptan, which gives it's a odorant designed to give a smell test to tell you have leaking gas. In production and gathering, when that gas comes out of the ground, it may have some hydrogen sulfide or sulfide or some things in it, but it does not have an odorant added. And if there's a low sulfur content in the gas, you will not smell that leak. But you might have an instance where you are called to a third-party damage or gas leak at a production or gathering line. Rare, but possible. The next intermediate stage is when they take that gas out of the ground, they process it, they clean it up, they scrub it up, and they separate the component parts of it. And the main product, methane, natural gas, is put in a transmission line, and that transmission line then takes it off to market where Northeast United States, South Coast, but these pipelines originate. There's a hub in Oklahoma where a lot of these gas lines come together, and then these gathering lines, and then they're distributed along main pipelines along the United States. These are very large metal pipelines, 24 to 36 inches, very high pressure, 1,000 pounds. And when you have an instance, they're catastrophic. When these things leak and you have an ignition, back in 2010, there was an ignition of a 30-inch, of a failure of a 30-inch pipeline, steel pipeline, in a residential area. There were 8 fatalities. You might have remembered it. And just recently in Texas, outside Houston, they had someone ran into a transmission station. A car ran out of control and knocked over a valve at a energy transfer station, knocked off a valve head or something, ignited, it was blowing for 3 days. They shut the valve off, but the problem is there's so much product in the line, they had to blow it off. Generally, these are going to be huge, catastrophic fires, and there's really not much you can do about them. Primarily, what we're going to be talking about is your local delivery. This is going to your houses. When the transmission line, it will then deliver to a city. It'll have a tap coming off it, and it'll go to the city of West Palm Beach, or the city of Oklahoma. And the local gas company will start to have this network of pipes that they go to deliver to local homes. This is where your vast majority of your responses are going to be. At this point, this gas will be odorized. It will have mercaptan in it so you can smell it. And usually, most of the lines get hit. Now, that video you saw just when we first started was a 2-inch line going down the street. That was a main. And that was a 2-inch in diameter, and all those houses were being fed off that line. So what will happen is, generally, though, most of the lines you will see will be service lines that are dug into by third party. They're usually 1/2 inch and 3/4, and they're usually always plastic pipe, and they're usually always less than 100 psi. All your residential services have low pressure. So what that means is, when you have that transmission, for instance, at 1,000 pounds, man, that gas, if that ignites, it's coming out at a huge rate. You got a blowtorch there. And it doesn't mean that you're not going to have a decent fire on a local delivery and break the line, but it's usually not as high pressure, and it's limited in the amount. So it's not nearly as uncontrollable as if you have a transmission line event. Most of the local, depending on the age of your system, old systems all had metal pipe delivering gas into houses. They're getting away from that as those services, those pipelines in the house age out, they're replacing with plastic. And you'll see more and more and more plastic pipe. Okay. So, as I said, in your delivery, when you're responding to a scene, you're going to see 2 types of pipe. The plastic, and it could be yellow, it could be orange, it could be black. There's a lot of different colors. And so they're basically all, they're all plastic. They color them differently. Plastic pipe, and we're going to be talking about this more in detail, it's highly susceptible to static electricity generation. And so consequently, that's what causes you a big problem. That's what ignites that ignition, when that third-party damage in Oklahoma you saw in the first video. This is the preferred piping material, and it's all metal is being replaced. Metal pipe is being replaced with plastic when it is time to replace the service. The only limit is plastic pipe is limited to about 100 pounds PSI. There's certain little exceptions, but as a general rule, you're not going to find any pipes, like gas pipes, that have over 100 PSI. Most of them will be regulated down less than that. In metal pipe, they can have a higher pressure, but even then, most of the time now in these metal pipes, they'll also be low pressure. They won't be high pressure. They are also susceptible to static electricity generation, but not to the extent of plastic. Now, you think because static electricity, you ground that out. Well, what everybody thinks is because it's metal, static doesn't build up. That's not true. The reason is there is uncoated metal pipe, okay? But they're phasing that out because it corrodes and causes leaks. If you put a coating on any metal pipe, those areas, those coatings oftentimes are electrical insulators on the inside and outside the static pipe, and static can build up in there. So when you think of static electricity in a local gas pipe, it can be in a metal pipe too. Okay? Now, real quick, we're going to talk for like 10 minutes, 5 minutes on what static electricity is, because we want to make sure everybody's using the same terminology. Electricity is electricity. There's the electricity is either static or current electricity, whether it's on a surface that's an electrical conductor or not. I'm sitting here in my home office today for this meeting in Boca Raton, Florida. And Florida Power and Light has a generator up in Juno Beach, Florida. And this generator strips off a pile of electrons and places them on copper wire. Now, copper by its inherent nature, can conduct electricity through it. It's inherent in copper wire. We call those materials electrical conductors. That is current electricity. So when FB&L puts those electrons on that wire, the electrons follow that wire and come around and deliver it into my computer that powers this presentation. Static electricity is the same electricity, except it's on a surface that's an electrical insulator and does not allow the movement of electrons. So, for instance, that same example, FP&L, they generate all these electrons. They take these electrons and then they stick it on a piece of polyethylene pipe. Those electrons are just going to sit there. They want to move, but they can't because the material they're sitting on is an electrical insulator. And so consequently, that electricity, instead of being current electricity that's flowing through a material that's an electrical conductor and has movement, static electricity is an electrical charge that can't move. It's static. Now, how's it created? It's created by friction. There's a lot of other ways it could be created, but in our instance, in the natural gas industry, it's caused by friction. It's the rubbing of two materials that are electrical insulators, and in the mechanical shearing actions, electrons get knocked off and they start to accumulate on these surfaces. And your problem is this in the natural gas industry, and the same with you. The problem is that Mother Nature's intended to be at electrical neutrality. Most things in the world are electrical insulators. They are not electrical conductors. If static charges build up, like in the up and down drafts in the summer, and the current in the charge gets big enough, the static electricity arcs to ground to neutralize each other. So that's what happens if you don't control that static electricity in the situation you're in. It's going to arc to ground and neutralize itself. And if there's a gaseous mixture around there, it's going to ignite. So real quickly, I'm going to take you through the 4 basics of static electricity in plastic pipe, because again, that's where most of your encounters with gas leaks are going to be in plastic pipe. But it does apply to coated metal pipes too. So that's important. This was done by a nonprofit called the Gas Research Institute. And this is the most fundamental thing you need to start. All static starts inside the pipe because that's where the friction is. That's where the movement is, where it shears off those electrons and they accumulate in the side of the pipe. And then here's the citation from Gas Research Institute. It's saying when gas is flowing through the pipe, that's how static builds up. Because remember I explained earlier, static electricity is electricity that is on a material that can't move. It accumulates. So it's just going to sit there. It can't go away. That's why it's called static. And you have to deliberately dissipate it, or it will arc to ground and dissipate itself. Once again, here's the citation from the Gas Research Institute. It also puts a charge on the outside of the pipe. I could explain it, but really it's not necessarily for you to do. That's why you have this dissipate the static on the pipe if you want to prevent an ignition. Once again, here's a citation from Gas Research Institute. And finally, static electricity. It's an electrical charge. It wants to go to electrical neutrality. If you have a gaseous mixture next to it, whether it's methane, propane, it can be butane. If you're happen to be hit have one line, a transmission line that's carrying butane, all of those things will ignite. Those static charges want to go to electrical neutrality. They will ignite if they are exposed to a charge and that charge is exposed to ground. That's the basics. And here's a citation about the problem with the static charge going to ignite. So here's what's happening. When you saw that video at the very beginning, where Oklahoma Natural Gas had gone out to a location where it's a cut in a gas line, what happens is, if you don't have a known ignition source, it's the flow of gas inside it. It's the friction of the gas going inside that pipe and exiting that pipe where the damage is, that the static builds up. And the probable cause, if you have an ignition, remember, you have to have you have to have an ignition source. And in the absence of any ignition source, if you've got an ignition of leaking natural gas with no known ignition source, then it's going to have to be static electricity. It must be. You've got to have it. And indeed, that's what ONG said when they had that line. Now, this is kind of interesting. Polyethylene pipe is a superior material for transporting natural gas. Doesn't corrode. You can hit it, and it's impervious to any kind of corrosion or degradation. You can hit it, it'll stretch, it'll give, it has some flexibility. The only problem with it is when you push natural gas through that polyethylene pipe, it creates its own ignition source, static electricity. And that's what you have to deal with if you go to response. And so here's what makes your situation a potential static ignition risk when you go. You have that interior pipe surface exposed, like that break in the line in ONG. You have a gaseous mixture, and then you have proximity to electrical ground. That can be a tool, that could be a worker, that could be dirt, any of those things. Memphis, Tennessee, November 26th, 2014. This is Memphis Lake Gas and Water. They had a crew out to do just a routine in the street maintenance. And what happened was they had a trench there. There were three guys in the trench and two guys standing beside it. And when they were working on the line, there was leaking gas, static electricity ignited. One guy died, four of them, all four were injured. And here is the OSHA report on that. And it shows that 5 employees were caught in an explosion due to a natural gas leak. Static electricity ignited the gas leak, and 1 employee was killed with 4 other burns. So this is what will happen unless you maintain and dissipate the static when you're approaching a natural gas leak. Now, we've been talking about polyethylene because most of you understand, you could tell that plastic is a natural accumulator of static electricity. For instance, the old kids' birthday party trick, you blow up a balloon, rub it against their hair, it sticks to their hair. But so if I tell you that static is very susceptible for buildup in a plastic pipe, that's not something that probably is a real surprise to you. However, most people think, well, since metal's an electrical conductor, you can't have static electricity in metal pipe. Not so. It's because there's still friction inside that pipe. There's still electrons getting knocked off. And what happens is, if you have most of the pipe anymore, they are getting rid of uncoated metal pipe because it corrodes. All pipe, steel pipe, metal pipe in the ground has coatings on it. And those coatings are basically, most of the time, they will make the material, that surface, non-electrically conductive. And therefore, a static charge can build up on that. This is a photo from AP, Hanoverton, Ohio, 10:30 at night, February 10th, 2011. This is a Tennessee Gas natural pipeline that had a failure in it. I don't know, I think it's probably 26, 30 inches pipe. They had a failure in it, and the gas ignited. Now, the reason I'm showing you this is, one, you're not going to be able to put this out. They have to shut the pipeline down and get the product out of it. However, if you take a look at this on the left, just to the left of that plume on the left, you'll see a shadow of a structure. That's a silo. This was a farm in the middle of nowhere in Ohio. It was 29 degrees. There was no weather, no wind, clear skies. My question to you is, what's the ignition source? How could this thing catch on fire in the middle of nowhere? It's static electricity in that metal pipe. When that pressure, that steel line failed, you had gas escaping. There's surfaces on there that are electrical that are electrical insulators. Static builds up on those surfaces. It gets high enough that all of a sudden it ignites the gas, and there you have a conflagration. Now, so you're going to find that static electricity is going to be produced in the flow of both natural gas and propane in both metal and plastic. You have to assume that to be the case. So if you're able to address the ignition site, the ignition source, after you secure the site, you can improve the probability that you can prevent an ignition. Now, so here we go. You're called, you got a gas leak. The first thing you got to determine is if the leak is locatable. Because if you're going to deal with the static electricity, you got to be able to locate the leak, because the static electricity is coming out from the place where it's leaking. It's created at the point of exit of the gas coming out of the pipe. You're going to have two situations. First one, if it's a migrating gas, that's where I know there was an instance once where a sewer contractor he nicked a steel line somewhere, and then he finished his work and just filled it in. And over time, that nick corroded and eventually put a hole in that little pipe, that gas pipe, and the gas started leaking underground and started migrating. And when you have there's no way you can find that leak. And what happened? It'll migrate into the sewer. It migrates into the basement of a house. You don't know. It depends on soil conditions, where it is. But the point is, if you have come into a situation where you have a migrating gas, there's nothing you can do. Your primary thing is prevent loss of life first. Prevent loss of life first. Property second. Get everybody out of there, and you're going to have to wait until the gas company can valve that off or shut that off. However, if you have a locatable gas line break, then you can apply static suppression procedures to prevent an ignition. And that's probably going to be a majority of the leaks you encounter are going to be these, where there's a locatable line leak. Generally, again, it's going to be caused by third parties. Now, here's just a real simple illustration of a leak. Generally here, this is my illustration in my school where workers have gone in to dig out and repair a leak. But if you notice in this illustration, you have a gas flow and you see these little red patches inside the pipe. These are the random places that static builds up on the inside of pipes. I can guarantee you with 100% certainty, if you have a plastic pipe, there's static inside that pipe. But at the same time, I can tell you with 100% certainty, I can't tell you where it is in that pipe. That's the bedeviling thing about static and plastic pipe, is you can't predict where it accumulates in pipe. But when you have a leak like this and you see where the gas is coming out, and you notice there's red along the edges, what happens is when you have third-party damage, or even in a repair operation when they've cut the pipe, if there's leaking gas, the turbulence around the edge of that causes friction, and the static starts to accumulate on the inside edges of that pipe. It also may be on the outside of that pipe too, because remember, we said that when static is initially generated on the inside of the pipe, it induces a charge on the outside of the pipe. So on that pipe, you're going to have static at the point right inside the edges where the break is, the damage is, or the cut, and on the outside surface of the exposed pipe. Now, what we do is we're in the static suppression business, and we have static suppression products. So what happens is you've got to suppress the static at that location in order to prevent a possible static ignition. So what you're seeing here on the right is our aerosol static suppressor. We provide that to natural gas companies. It's used by most of the natural gas companies in the United States. When they go out to a repair operation, the first thing they do is they spray the pipe to dissipate the static to make it safe to approach. And so when you have a blowing gas line, what you want to do is you want to try to dissipate the static in the location. Now, if you have a blowing line, and this is what I tell my natural gas companies when they go to a third-party damage, you want to try to spray an anti-stat to get as close to the break as you can, wet that area, so you dissipate as much potential static as you can. Now, the problem is the exiting gas at pressure is going to push the aerosol, the anti-stat away. That's okay. At least you're getting something on the line until that time where you can stop the flow of gas. Remember that we have a pole for the aerosol so that you can apply it from a distance, because distance is your friend. The farther away you are from a potential ignition, the safer you are. So what we do then is when you have that exposed or that damaged pipe available, once you shut it off, then you want to spray it again, because you want to get inside there and make sure you dissipate the static. You're going to have methane laying around there, okay? There's going to be methane in there. But if you've taken away the potential ignition source, you greatly reduce your risk of an ignition while you're there. Okay. Now, I want to talk to you a little bit about working with your local gas company. If you don't have any kind of coordination with your local gas company, here's what I'd suggest you do. There are, down here in South Florida, we have numerous fire rescue guys that put our aerosol on the truck, and they've worked out a emergency response coordination with the local gas company here, TECO, Florida Public Utilities, people like that. And basically, you need, first of all, find your emergency response coordinator for that local gas company. Get with them, and then you need to determine what degree they'll let you touch their pipes. Remember, that's theirs. Now, for instance, Manatee Fire Rescue, TECO is a local gas company. They have made an agreement. They can work on pipes less than 2 inches. So if they come to a leaking gas site and it's 2 inches or less, then they're allowed to go and start to try to, to secure the site and maybe pinch off the pipe. Now, so you want to find out, usually 2 inches, that's a fairly large pipe, but because most of the time your service lines are going to be 3/4 to 1 inch, maybe possibly even 1/2 inch. So those are fairly safe. 2 inches, that's a pretty big pipe if you're going to try to manhandle that. But one of the things that some gas companies do, or some people do when you have a blowing line, is they will bend the pipe, like you bend a garden hose to stop the water flow. You can't do that with a metal pipe, obviously, but you can do it with a plastic pipe. And so you should have some kind of criteria with them about what that you can bend if you want to stop the flow of gas, okay? And that depends on the pipe size. 1/2 inch, 3/4, maybe even 1 inch. It's fairly easy to do. And then you ought to have a valve policy with them. What I mean by that is, in the local gas companies, unlike in the upstream production and gathering of natural gas, in the downstream market, there's not a lot of valves. Most of the time, when gas companies want to shut off flow, they pinch the pipe, they squeeze it off. And so consequently, they don't like you turning off valves because you don't know what valve does what. And so consequently, you need to get with them and decide when and what valves you're allowed to close. Okay. Now, when you've found this locatable leak, it's blowing, and you want to bend the pipe. If you do, remember, I want to explain something that happens when you do bend the pipe. What happens is this. There's what's called the Venturi effect. As when you take a pipe and you start to reduce the dimensions or start to squeeze it off or bend it, what gas will attention when it's under pressure, what it'll attempt to do, it's called the Venturi effect. The gas will start to speed up to get initially, it'll start to speed up to get through that restricted opening. And in doing so, it has increased friction on those two areas when the surfaces are coming together. Now, there'll be a point where it will stop, of course. But what happens is when you bend that pipe, if you have a policy that they let you bend the pipe a 2-inch, a half, a 1 inch, or a ½ inch or 3/4 inch pipe, and you start to bend it, you've got to understand you're creating static downstream where you bend that pipe when you go through that motion. So you have to be very careful of that because you're creating static on that. Our aerosol, now, if you decide you want a lot of Manatee, Palm Beach Gardens, West Palm Beach, these guys, they keep a can of our aerosol on their truck. Now, it's important if you understand that there are other over-the-counter aerosols, anti-stat aerosols on the market. However, they are not suitable for gas emergencies, and here's why. Most aerosols in the United States are considered hazardous. And the main reason they're considered hazardous is because you have to have a gas inside the can to push out the product. And most aerosols in the United States use propane. And the reason they use propane is it's cheap, it doesn't react with any chemicals, it's solvent, it mixes in well with the liquids, it compresses well. Well, the problem with that is you don't want to have potential gas leak and be spraying something that has propane in it. And there's propane. The way you can prove there's propane in it is, like a deodorants and everything. As a kid, you'd press the button and you'd get a match and you'd have a blowtorch, and that's the propane inside the aerosol. We use nitrogen as our propellant in our aerosol for the natural gas industry. It really pushes out the oxygen and therefore enhances your ability to prevent an ignition. So what happens is most of our gas companies and the fire companies will have a can of our aerosol on their truck in order, if they're responding to a gas leak, in order to spray that pipe to make sure that it's safe. And what happens is it dissipates the static instantaneously, okay, because it works on a chemical basis. That's our reach tool for it. And let me just show you. I want to show you this. This is a demo that we did to show the effectiveness of our aerosol, but I want to put it on here for this reason. Take a look how easy it is for me to generate static on this piece of poly pipe. All I'm doing is rubbing it with a plastic, with like a polyester cloth. And just take a look at how easy it is to get a charge buildup, because that's an electrostatic voltmeter. And what it does is it measures the static on a surface. And I just rub that for a few seconds, and you see how fast static electricity built up on it. And that just shows how our static suppressor distributes it. Okay, so our aerosols, $14.50 a can to $16.50 a can. There's a reach pole. You can call us or order. We have an online store you can order it from. And this will be in. We're going to have the recording, and you can, if you're interested, you can get it there. Now, so summary. Your first priority is to preserve life, then property. We have to drill this into the guys and the natural gas side. Preserve life first, then property. You presume that static will be present in a blowing gas line, whether it's metal or plastic. Distance is your friend. Prevent the probable ignition source of a leaky gas pipe by suppressing static electricity. Coordinate, get with your emergency response coordinator, your local gas company, and determine a standard operating procedure of what you can and can't do. The maximum size pipe you're allowed to address, any meter valve shut off, gas flow stoppage, if you can bend the pipe, whatever. I'd suggest 1 can of aerosol static suppressor on a responding vehicle. I have one additional resource for you. Now, what I've done is I've been very focused on talking about static electricity in leaking gas response or a fire response. I did not talk about staging, how to come, and all that. National Grid, which is probably one of the largest natural gas companies in the United States, they're all in the Northeast United States. They have a PDF called First Responder Beware. Here, if you want a much more comprehensive, beyond dealing with static electricity and a leaking gas line, a more comprehensive resource to just develop some standard operating procedures for your departments on responding to natural gas emergency. Here is the URL. It's very good. It's a PDF and you can download it. So with that, we are done. I appreciate your time. Let's see. Yep, we hit 40 minutes. You're going to get a link on a recording. I want to thank you for being here.